Dave, why don't you demonstrate the program? And then you will see what we can do with that program. We can substitute in there quite a few parameters that you will find, no doubt, interesting. Give us an explanation, Dave, what the students can do with this. Oh, let me show them an overhead here, which would help you in following what Dave will be telling you. You see there the F value is always 5% we took. And you're going to see here the numbers for the number of times that Mary passes through point X and the number of times that the sandwich will pass through point X. This is that very first case that we worked on together. Here you see that number minus 0.017. And you see indeed that it's a successful catch. So let's work at that first. David, explain how it works.
OK, well, you can see in the middle of the screen is planet Earth. And these two triangles represent the astronauts. The yellow one is Mary, and the red one is Peter. And he's holding the sandwich right in the middle. They start off at a radius of 22,000 kilometers from the center of the Earth. That's the default, but you can change that if you'd like. And we set NA and NS through these pull-down menus. So we'll set them both to 1 and 1 now. And we ask the program to calculate the value for us of this dimensionless parameter. And it comes up with it. And we want to use that value. And so we have everything set. And then
there's this number, right, Dave? This minus
yes.
0.0175, et cetera. Yeah.
It's right over here. So then we ask the program to prepare the toss. We click this button down here. And when it's ready, the green play button will become active. And when that happens, we can click on that, and it'll play the toss for us.
Peter always throws at X.
Yeah.
12 o'clock.
Always at 12 o'clock.
There goes the sandwich. You see the sandwich? Great sandwich. Big sandwich. So notice that the sandwich makes it around exactly at the same time for Mary to be happy. Now, there's no reason why we shouldn't try 1, 2. So that means Mary reaches point X, but the sandwich went twice around the Earth. There is no problem with this solution in principle, but you have to be quite far away from the Earth. If you're too close to the Earth, like Dave's orbit, which has a radius of only 22,000 kilometers, something very catastrophic will happen.
Yeah. OK, so now we want to set an S to 2. And we do that with the pull-down menu, and we ask it to prepare the toss again, and it goes through its numerical calculations of the orbit. And when it's ready, it'll let us know. And now we can watch the toss.
So there goes the sandwich. It wants to go around the Earth twice, but it hits the Earth. That's too bad. If you make this dimensionless parameter -1, then v of s is 0. And what does it mean that v of s is 0? That the sandwich stands still, has no speed in orbit anymore. And so what happens with the ellipse? That becomes radial infall. Dave?
OK, so if we want to use our own value for this dimensionless parameter, then we can go to this box right here and put in whatever we want. So we'll put in -1. And we make sure that the program is going to use our value instead of the calculated value. In this case, these numbers don't matter, NA and NS. They're irrelevant because the program is going to use our value. We ask it to prepare the toss again.
The -1 overrides everything else now.
Yes. Going through its calculations, and now we can see what happens.
12 o'clock, there goes the sandwich. Now Peter decides at one point that instead of throwing the sandwich backwards, he can also throw the sandwich forward. Because look, we have here the red ellipse. There's no reason why Mary couldn't go twice through X, 1, twice, and then the sandwich would make a larger ellipse and meet here when Mary has gone around twice. Then, of course, the sandwich has to be thrown forward. And so Peter makes a calculation for what we call the 2-1 situation. Mary goes twice through X, the sandwich goes 1 through X. But Peter made a mistake. Peter got nervous, and he puts in the wrong parameters, and you will see what happens. Dave will first show you the right parameters.
Okay, so if we would have asked the program to calculate it for the case of 2, 1, it would have come up with a value for this dimensionless parameter of 0.1659 or something thereabouts. But Peter made his miscalculation, and he wants to use 0.164. So this is what we'll put into the program, and we'll prepare the toss and see what happens with this value. Okay, now it's ready.
Poor Mary must be hungry by now. There we go. Now you go forward. You can see that. You see it goes forward. It goes a very large ellipse. And Mary will go around twice. When Mary is here, see, the sandwich is only halfway. And if Peter had only done it right, Mary's troubles would now soon be over. But Peter made this small mistake, and Mary cannot catch it. If you make this dimensionless parameter plus 0.42, then it's very easy to convince yourself that the sandwich, it must be a plus, will have the escape velocity from the orbit. Maybe Peter got angry at one point at Mary. You never know about these situations. And he threw it very fast, and Dave will show you what happens then.
Okay.
And it goes to infinity. And it won't be fresh anymore when it gets there. Okay, see you Friday.